I'm just going to ask to raise of hands. Has anyone seen the Rockwood Academy before? No. Awesome. Well, that hopefully means I'm going to have a new, 100 subscribers, 50, whatever the number is. Please check out my channel. I try and make it my mission to make cloud-native Kubernetes microservices just easier for everybody. And one of the ways that I do that is through a show called Klustered. If you haven't heard of the Rockwood Academy, I'll assume you haven't heard of Klustered, but we'll get into that in just a moment. So, Klustered was the worst idea I ever had. I decided through hubris that I could provision a bare metal Kubernetes cluster, give some random people access to it on the internet, always a good idea, and allow them to break it in any way that they wish. At the start, there were no rules in Klustered, except that the machine has to be able to boot. That was it. So once you've broken the cluster, in the early versions, I would go on with a guest and we would work our way through debugging what is wrong with the cluster and hopefully fixing it. And we actually had a really good success rate and a lot of people get to laugh as we debug stupid problems. We then added a team edition, and I'm going to show a couple of clips just to give you a taste of what Klustered is and then kind of share some of the lessons that I've learned. But team edition was just this whole new dynamic where we had teams from Container Solutions. We've had teams from Isovalent, teams from Red Hat, from Talos, from Civo, DigitalOcean. Any major company in this space has probably had a team on Klustered do the exact same thing that you're about to see. Now, the first lesson, of course, is that people are really mean. When you give them access to a cluster and say there are no rules as long as the machine boots, people get very creative. And you're going to see just a few examples of how mean people can be.
We still have no cluster DNS. KubeDNS has endpoint. Okay, that's after 8.
Yeah.
Let's see if Guy wants to jump in and give us a last bit of advice before we wrap this up. Are we close?
You've not looked at the configuration of core DNS. You've looked at the pods, but not how the pods are configured to run the DNS.
We have no DNS. Keeps coming. All right. Did we miss something? Let's. I'm going to say cheat. I'm going to jump onto cluster 14 and grab the config back and see what's different.
What about?
Yeah, these are the exact same file. Yep. So he told us to look in the core DNS config, and then there was nothing wrong with the core DNS config. That's just cruel. Saying there's a few pixels. If this is a white space error in the core DNS config, I will be mighty frustrated.
It might not be a white space error. Damn.
He's mocking us now because he said your jumping back and forward showed a slight difference. This number seems arbitrary. Oh, you son of a bitch. I'm assuming there's like a weird bug, and I'm sure he's found it because he works at Skyscanner and they've got a level of scale that most people don't have. But something to do with this number going so high is maybe causing it to load an old config map in the pods or something. I don't really know. But the number being so high worries me. But we're now at the stage where I have to go and pick up my daughter. So
yeah,
I'm just going to bring Guy in to tell us what wonderful magical
what we should
crap
do.
this is. Yeah. All right, Guy. Lay it on us.
So when you were jumping back and forth between the working config and the non-working config, if you look really hard at the C in front of it in the Kubernetes config.
Oh, you bastard.
The C?
Yeah, it's not a C. No, it's a character which looks a lot like a C.
What?
So the Kubernetes plugin became authoritative for letter that looks like a C, luster.local.
I fucking hate him. 2 hours we were fixing that. So there are now some rules. No Unicode. But that's clustered, right? People can do anything they want to these, and we just try to work backwards with whatever symptoms we have and try to show people really the guts of how a Kubernetes control plane works, and even the Kubernetes API surface itself with custom resources, etc. So go check out Klustered, subscribe to the channel, and now we get to look at a few more things. And what's important with this talk is that there are a lot of failures in Klustered, right? We experience a lot of broken things. We can't always fix them, but right, none of us have any intrinsic knowledge that we're born with Kubernetes, right? You have to suffer a lot of failures. You have to see a lot of shit before you really understand how to make this successful within your organization. I'm sorry, I should try not to swear before noon, right? So we're going to take a look at the different attack surfaces within Kubernetes, the way that people have broken them on the cluster. I'll share some of these with you so that you have an idea of what to expect. And then I'm going to share a little bit more about what I think is a superpower for observability and debugging within a Kubernetes context. Now, I want to show one more clip, and I promise it's really short, just to show you another really cruel thing that was seen, and then talk about Linux and the aspects of Linux that you may not be aware of.
Free to just go or what?
So nice.
Yeah.
Get some notes, man.
Let's see. Permission denied.
Oh.
Let's check.
And you've hit your first snag. There we go.
Okay, make it +X.
Yeah. I need my autocomplete stuff. I'm lost.
You didn't install fish while you're here too?
I can type if you want.
Oh,
Okay.
Nice.
okay.
It's an interesting start.
Yeah. Do an ls-l-a on user bin change mod, or probably just bin change mod. Oh, bother! You don't even have tab completion? What
No,
is
I
this?
don't. Yeah, it's killing me. But hey, we'll make it work.
If you don't, I think that's
Oh, wait.
probably because
We
they've
can't
No.
mod that.
Yeah,
Well,
exactly. So let's just look at the whole/bin. Is there anything which is executable at all?
Well, ls is obviously.
Okay, so I'd like to stop this one here. I'm assuming you're all familiar with what the green color means, right? These are the files that we can execute in the bin directory. Let's look at the ones we can't. Kubeadmin, kubecontrol, chmod, change attributes, Perl, Python, SCP, SSH. Who knows how to fix this cluster? All right. What I loved about this episode was complete serendipity. We had a team from Red Hat. They were the breakers. They know Linux inside out. They're Team Red Hat, right? Anyone know who this team is? This is Talos Linux, Sodero Labs. They actually have a bespoke custom operating system with a replacement PID1 that runs all over gRPC for managing Kubernetes. They also know Linux. And they actually did get past this really quickly, and I learned something really, really cool. And that really cool thing is, well, the way I would have fixed this would be in Perl, but they actually removed access to that. We've got change attributes. Anyone know what attributes are in a Linux file system? Right, you can mark files as immutable, and they can never be edited, for instance. But not a lot of people know they're there. And you kind of need kubeadmin and kubecontrol. But what they did to fix it was they proxied the chmod command through the dynamic linker. You can actually execute any binary on the machine by using libld.linux.so, like that. Isn't that a cool trick? Awesome. So yeah, lots of serendipity and Klustered, and we learn lots of really cool hacks, cheats, and other things along the way. File attributes have been exploited numerous times on Klustered. You can do ls-atter on directories and files, and if you see the immutability flag there, it means that you can't edit it. Also means that for executables, you can't actually execute it either. So change attributes is a way to remove the immutability flag, and ls attributes is how we can actually have visibility into that. And again, not a lot of people know this stuff, because why would you, unless you get presented with a problem that exposes these APIs to you. Like standard Linux file system, we just use ls. ls-l if you're feeling brave, right? So, another really great episode. I'm not going to show any more clips because it's only got 30 minutes, but we had Chris Nova. Everybody knows who Chris Nova is, right? Okay, kernel hacker. Not a good person to invite onto Klustered. They deployed a rootkit to the entire machine. Replaced the kube API server, made it do really stupid stuff that it shouldn't do. However, Chris was up against Thomas Stromberg. Does anybody know who Thomas Stromberg is? Right, he was a Google engineer and he was a maintainer on Minikube. Very experienced, has been doing this for 20, 25 years. And as I learned on the episode, previously worked in the forensic analysis for intrusion at Google. And he busted out something called SleuthKit. Last question, who has heard of SleuthKit? Right, nobody. Cool. It's a tool that's used to analyze the file system and detect changes over time. With this one command, FLS, he was able to get an entire change log of every modification to every file on that machine, time ordered. That is invaluable, especially on Klustered. So he was able to detect where the rootkit was, what parameters were modified on the API server, the fact that the API server binary has even changed, and he was able to just work through backwards. So SleuthKit and FLS are fantastic tools to add to your arsenal if you ever need to debug malicious activity within your cluster. And again, complete serendipity. Did I know this was going to happen? Of course not. But you just put two smart people against each other, let them have some fun, and good things come out of it. So that was Linux. Of course, I have to talk about networking. People get a bit worried when networking stops working on their cluster, because networking is, again, very, very difficult. And I always try and encourage people to use Cilium. I just think it's the best CNI that we have access to, and it gives us insane visibility, observability into everything network related within our cluster. Of course, you have to understand that it brings with it its own CRDs. While we have network policies available in Networking v1 APIs, Cilium also has their own networking policies. Here's a fun question for you. Who knows what the default DNS policy is within your cluster? Yeah, not default. There's a DNS policy called default, and it isn't the default. This stuff, again, is hard. It passes the eyeball test, but what actually happens with the default DNS resolution is that it's going to go straight out and look at your default resolver on the host, bypassing core DNS within your cluster. And then we've got IP tables, right? I'm sure enough of us here can run IP tables-L and flush and hope that magic just fixes itself, right? But actually underneath that, we've got EBNF, we've got quality of service with traffic control, and then we've got eBPF and extreme data path as well. The networking landscape is changing drastically and has done over the last 5 years compared to the last 10 or 20 years before it. So I do strongly encourage people to check out Cilium. Tip number 1 for debugging within a Kubernetes cluster is to use Hubble. Hubble is this UI that you get with or from Isovalent as part of the Cilium open source project, which actually allows you to visualize all of the services and pods within your cluster and the networking policies with how they communicate. Very, very cool tool. It will actually show you when traffic is being denied or blocked going from one pod to another via all the network policies in your cluster. They also have a CLI. I actually did a special edition Klustered and invited Team Isovalent onto it, and I used Cilium against them. They have a custom resource called Local Redirect Policy. This allows you to locally redirect services on each individual node to other services within a node. Typically, it's used for node local DNS to avoid kind of breaking your DNS server. However, as you can see here, they were observing all the traffic on port 5432. The port, of course, is Postgres. However, my local redirect policy was sending them to a pod called FluentD. However, they were able to debug it with the Cilium CNI in just a few moments, gave them enough information that they had to go and find the local redirect, and they removed it. One more tool from the team at Isovalent is the Cilium editor. You can go to editor.cilium.io, and you can actually paste in your network policies or load some default policies from them. Or if you really want to do this on easy mode, you can add new boxes, drag little lines, and say, I want all these services to be able to communicate with this. And then it gives you the networking policy at the bottom that you can copy and stick into a GitOps pipeline. It allows you to do standard Kubernetes network policies. So even if you're not using Cilium, you can still use the Cilium editor. However, there is a toggle button at the bottom if you want a Cilium network specific network policy. So go check out the Cilium editor. Now, after networking, we move on to etcd. Who's had to debug problems with etcd before? Right. I guarantee you, I always poll people after Klustered and before and ask them what they don't want to see. Most people get really upset when there's an etcd break because we just want it to work and we never want to have to dig into it. Or you're using managed Kubernetes and you've never had to actually experience or deal with etcd in the first place. And even configuring the etcd control CLI to speak to etcd requires a ton of environment variables just to get started. It is a super challenging thing for everybody who has been on Klustered. So here's some good tips for etcd management. 1. You can list the alarms, which will tell you if your etcd is in a state where it's unhappy, which means it's probably not going to accept any new writes, meaning you cannot do kubectl edit or apply or even delete. etcd is also configured with a maximum storage size of, I think it's 25 meg by default. Once your database gets bigger than that, you can't write any more pod. You can't create pods, you can't delete, you can't do anything. And actually resizing the etcd database isn't that difficult, but it doesn't remove the alarm. You can restart etcd, everything looks okay, but you have to manually go in and disarm the alarm with the command. Why? Because etcd hates you. So it's just, again, these are things that until you've had to do this, you just don't know that these are going to bite you on the ass later. On another very difficult episode of Klustered, of which I was a fixer, someone enabled encryption on my etcd database and did not encrypt all the contents for me. Wasn't that fun? However, we learn through failure, right? You can enable dual mode on your etcd. So if you are going through the path of enabling encryption on your etcd database, you can actually just add a blank identity list option, which means that it will accept unencrypted and encrypted data keys. And the best way to encrypt all of the information in your etcd database is actually just to run kubectl get secrets on all namespaces, spit it out as JSON, and apply it directly back to the cluster. So, top tip. Moving on from etcd, what do I want to talk about next? Well, we're all operating, I'm assuming, Kubernetes in some capacity. We're not all going to have the same path. We're not all going to be learning the same things at the same time. So it's really important for us to have conferences like this where we can come and share stories. But for me personally, I built a word cloud of all the breaks we've seen on Klustered over the last 70-ish episodes. And you can see the attack surface is pretty large. You can attack the container runtimes, whether that be Docker or Containerd. You can attack the Linux system. The CSI drivers are always very popular. Did you know you can disable individual controllers on the controller manager? Why? Who knows, right? But you can. You can turn off the pod controller. You can turn off the replica set controller. You can do kubectl apply to your heart's content with all the deployments in the world and be sitting there going, why are there no pods? Because someone maybe turned off that individual controller. You can actually run the kubelet with a flag called run once. It means the kubelet starts up, it looks good, and then it shuts back down. Why? Come on. Now, I actually did some research and went through all of the pull requests for the kubelet run once flag and the issues and the keps. And it turns out there was a valid use case. And it is because before we had kubeadmin, you could actually run the kubelet as run once. It would bootstrap itself as a static manifest and would be under its own management, which makes sense. But of course, best practice now is to have the kubelet run as a systemd process. However, we're going to have this run once flag forever. Now again, really important, you only know this stuff because you've had to fix it in some capacity at some stage. Again, you're not expected to know all of this stuff in your careers and on your job, and it's only through failure that we build up this knowledge. And I really want to kind of normalize the idea that it's okay to say, I don't know. Like, it's really scary to jump onto a live stream for 90 minutes with a broken Kubernetes cluster, have no idea what you're going to experience. But the people that do well at it are the ones that are comfortable just saying, I have no idea what's going on. They open Google and they start working backwards. We all do this, right? So we really need to just encourage people to feel comfortable with I don't knows. And you'll see these quotes here that have been scattered throughout the talk as well. These are all what we would consider some of the greatest and smartest people in their fields. And all of them understand that failure is the way that we improve. Oh, sorry. No, on you go. All right. So we all find this difficult. If you can and you are interested, learn in public. Start your own YouTube channel, open a Twitter account if you're not on it, share your stories, write a blog. The more we build up the collective knowledge for Kubernetes, the more that we can all learn together and make our lives all a little bit easier in the same time. So what I am most interested in right now, and I'm assuming we're at SRECon, or what the fuck is SRE, right? That eBPF is something that we're all, either our interest is peaked, or we're going down that rabbit hole already and we're starting to play with more and more eBPF on a weekly or daily basis. Why am I interested in eBPF? Well, one, the performance of having something run it's extremely fast. It gives us insights and observability into the Linux kernel and the programs that run on top of the Linux kernel in a safe way using a sandbox which is guaranteed not to crash. There's a lot of strong benefits for eBPF, and we're already seeing cloud-native companies really go all in on this technology, like Sysdig with Falco and even Isovalent with Cilium. Cilium is an all eBPF networking engine. Inspector Gadget by Convoke has a very good set of debugging tools. If you've not checked that out, it allows you to run eBPF programs within your Kubernetes cluster to improve your debugging. And monitoring is now easy, right? Anyone heard of Pixie by Pixie Labs, right? It's this amazing technology where you don't have to instrument your code with Prometheus metrics or OpenTelemetry or anything. It runs a set of eBPF probes within the kernel and will tell you how your application is running, and you don't need to do anything. They support PHP, Perl, Ruby, C, Java, Go, Rust. It doesn't really matter. As long as they have access to stack frames within the kernel, you get monitoring and tracing of your application with zero code. That is extremely powerful. Also, why New Relic bought them. However, Pixie is open source, so you can use it safely without paying the New Relic fees. There's also a set of tools that I'm going to do like a 10-second demo of. These are the Snoopy programs. These are all the example binaries that are provided by the people working on eBPF. The two most important ones that I love to show are exec_snoop and OpenSnoop. So let's take a look at them. This is my demo server that I brought. I'm a big fan of bare metal. So we have 64 cores and 252 gig of RAM to run 2 commands. I just like to share that because it's fun. So I'm going to split my terminal, open a second one. Thank you, 1Password. And I'm going to run OpenSnoop. So this is an eBPF program that hooks into the syscalls within the kernel and will show you every time a file is opened on a machine. And as you can see, we've already got stuff. But this is great for security, because assuming someone starts poking into your password file, we now have an eBPF event that shows us the process, the user, and more information. It's all available there, and we can get it. So we can start to hook this and monitor for access to sensitive files within our machine that we don't expect people to be playing with. Okay, let's run one more. Let's do exec_snoop. This will show us every time a new process is started. I run ls, I can see all the information there. Not that useful for ls, however, if I run echo hello as sudo, we now can have access to every time the sudo command is executed on our machine. You may want to build a pipeline around this and monitor for usage and make sure that you understand when people are elevating their permissions on your hardware. And that's just scratching the surface of what is available with eBPF. Like I said, there are a ton of tools. StackSnoop, TCP drupes, these give us access to complete networking when TCP connections are opened, when they're closed. You can do TCP life to understand how the connection progresses over time. You can monitor contract with it. There's just so much good stuff. So go check out those programs. And if we take a look at a Kubernetes risk pyramid here, this is by no means science, right? This is just me making something that hopefully looks quite decent and it helps explain a point. But high risk is the host system, right? If people get access because we have SSH available on our production infrastructure, there's a lot of bad things they can do there. And with a couple of eBPF probes or programs, we can monitor for sensitive file access and for sudo access and other elevated privileges. Moving up the pyramid, less risk, right? But lateral movement from a pod is something that can happen in your cluster. If you have a CVE running and someone can exploit that to get a terminal inside of one of your pods, and they can move around the pods, eventually moving around namespaces, somehow getting onto the host, that is a risk. And again, eBPF gives us visibility into all of that too. Completely low risk because it doesn't happen very often, but container breakouts are a threat. And again, eBPF gives us the tools to monitor for the syscalls that would be used in order to escape from the container and elevate privileges towards the host. So eBPF really is a superpower that you can start to learn today. If you want to learn more about eBPF, Brendan Gregg is probably one of the more canonical resources. There's an entire book. I believe he's still at Netflix doing performance and other cool stuff there, but go check out the Performance Tools book. The Snoopy tools that I ran all come from the BCC IOVisor repository, so go check them out. The code is really easy to understand. To write an eBPF probe to monitor sudo access, file access, is just like 10 to 20 lines of code to inject that probe. You can do it in Python, you can do it in Go, you can do it in Rust. So go check that out. And if you're feeling particularly sneaky, there's the eBPF rootkit developed by the team at Datadog. This is an almost undetectable rootkit that you can run on a Linux machine. Why is it undetectable? Because, well, eBPF is really powerful. Actually understanding what probes are running on a machine is still relatively difficult, but that tooling will improve over time. But it's a good project to have a little play with. Whatever's next for you, again, please remember to come and share your stories with people at conferences, on Twitter, on blogs, and even videos on YouTube. I'd love to learn what everyone else finds exciting right now and share and build our collective knowledge. Thank you very much for your time.